Alright, the transition from 2D to 3D is done in fits and starts generally. That means that there are sometimes you're working in 2D to make it 3D, sometimes 3D to make it 2D. And Civil3d actually does a lot of work in 2D to make you then make a 3D world. The first objects that came into 3D for you are the topo lines, and that's why generally you go about, when you're doing design work, turning off the topo. So for instance, if I turn on my topo here, you'll realize that each of these lines here are in 3D. So if those lines are around and you say line and your snaps are on especially, or you say near to here, and then draw that line, list the last line, you notice that it was up at elevation. So the first thing you're going to want to do until you're really good at not snapping or snapping when you want is to make sure that your topo or your surface is not shown where you can grab it. So usually you're going to have that thing out on the end. The other thing is to be aware that it's important to have 3D lines around, but very often you're going to want the important lines like section lines, 40 lines, quarter section lines down at layer 0. I'm sorry, at elevation 0. However, it's quite useful to have 3D lines, and so if you noticed here I had brought this surface in at layer 0, or at elevation 0, so I can do something like this right now. I can do a P line from the end of this one here. Think about that, from the end there. And if I go ahead and hit on my ortho key, which doesn't always work because I've got another program going with that, so I can go ahead and say at 100 angle west. And now I can trim sometimes. And it does let me trim to that. So I can think about this. I'm going to trim back here to there just to get a concept of how wide my road was. The first one was, I'll trim again here. So the way I had that road work done, the length of that line, which is a flat 9, is 12. I can extend, screw that, trim off that end point again, and I can do list again. So we get a general sense of how that road is laid out. So I'm going to go ahead and just quick give this road, and it's not necessarily true, I'm going to give that road elevation now of 1%. And again, since I'm working in the real 3D space, that 1% is not going to be times 10. So I can take this right here, I can grab that, I can squiggle it around, I can know that I was 2640, so I want to drop that down 26.4 feet, so I can say at 0, 0, minus 26.4. Now if I look at that road, you see that it's dropping down, and that's not the case that we have out there, but we can do all kinds of different manipulations with 3D space to get and build another tin here. So I'm going to go out and do the same thing here and provide that information for you off of the USGS map, but realize that once you have something there, if this was your road, such as the case would be, you could then offset. You have to be careful about offset, but offset 12 this way and 12 that way. You could now grab those two. You could grab them by the ear, space bar, and you could say at 0, 0, minus 0.24. Right? I'd want to go ahead quickly and change the color on those. They would be, in fact, maybe I'm keeping track of the side of the road by green. And now if I do a line from near here to near there and did a list on that line, you see it's actually dropping down the cross slope on the road. So that's how one sometimes goes about keeping track of doing 3D lines, guessing them in, and actually designing in 3D space. So that was working in 3D. I will provide a road out here for those of you who want to extend your tin out to the north right away. Again, that was not surveyed here, but we should be able to get some inclination of what's happening out here on the road from your surface points along this side here. All right, so that is a quick 5-minute discussion on 3D space and 3D lines versus 2D lines. Of course, you want to know how to look at these, and so I'm going to show you basically one thing to avoid is to use, when you look at these different views, is to use the views that the program gives. You want to actually use the viewpoint, because it does not change your coordinate system in any view. And I'll let you know that's bad juju, as they say. So viewpoint. I'm going to go ahead and do viewports, and I'm going to make 3 left like that. And you'll see later on that's a very typical design space if you've got a couple of screens. And this one here, I'm going to actually go to the front view, which is going to be viewpoint from 0 in the X, -1 in the Y, and 0 in the Z. I'm looking at this, and if I look at right there, I can see my work right there, and you see how nothing gets everything's either flat at this down or flat up on where the surfaces are. This one here, I can do viewpoint 1, 1, 1, and once again, you would want to go ahead and save these views right now. So I've got a viewpoint there and a viewpoint there. I could right now go -V, save, give this one is a from south view, and this one here, UCS, minus view from north east. So I'm saving this time not views with a view frame around it, but I'm saving actually views so I can do it later. I'm going to go ahead again, save from north east. So later on I can come back to these views quite easily without kind of clicking around on my mouse. And I'll show you what I mean now in these 3 views. If I'm over here now and I do a line from the end point of this to some point here, you see how it shoots down. And that's because lines are not fixed in 2D space. However, if I do a P line from the end point here and then arbitrarily pick over here, everything stays flat no matter what I have around. So I can even have the 3D topo lines up and end up more than okay, but still not a good idea to have them around. So that's kind of learning to control some of the tricks within AutoCAD, which is going to pay off in however you're working within 3D. But realizing we are then dealing in this space, and you might have then another viewport around when you finally talk about dealing with your profile view. That is how you're going to read plans. At this point in time, you're going to be looking at plans and profiles. And so you want to get used to, on this design space, to having your plans at whatever your northings and eastings are for your coordinate system, state plane central or the county coordinate system. You want to have your profiles at station elevation times 10, and then you want to learn to deal with 3D space. All right, that said, the last thing, when we look at these things, you want to make sure we have views for everything, and you want to tend to write things down. And in this case, I'm going to stop here at about 10 minutes, and I'm going to come back and show you that, in fact, it's probably worthwhile at some point to get the habit of jumping all the way out to the right of way. So you notice that this alignment here is going from center line to center line, but in reality it would be a great idea to begin out at the right of way or some line farther outside of where you plan on matching at an intersection. It'd be a good idea to know the stationing of where you match and the elevation, so you have what's called a match point or a place to put a station equation. And so I'm going to do a little research out at the in this tin and out at the USGS map and come up with an approximate road up here, just like this road out here towards the east was approximate. And that's very normally done if it is then notated on the plans with, verify elevation, or more likely than not, you would send a field crew out there, or you drive by and with a level and get that match elevation, because that's going to be the kicker. Thanks for listening.